Hi everyone, welcome back to my series on A-Level Statistics. This series is a fresh start on the previous series, but with the promise that I will try to publish at least 2 videos per week until the end of 2024. I do aim to produce more per week, but I will publish 2 weeks, 2 videos a week, regardless of whether I'm on holiday or any other thing. I had to stop the previous series back then because I had some personal issues to deal with, but I hope this year goes good. So what's going to be covered? Again, I'm going to be aiming for A-level statistics at Excel. We will be covering all the content. I will be using the A-level textbooks we used in the last time, same books, but we'll have a slightly different approach than last time. This time, rather than going from almost a jump in. We're going to start from the complete basics, learning the terminologies, and then we'll go on from there. So this video will focus on an introduction to statistics. So another question comes, what really is statistics, right? So could it be the manipulation, going to a shop and asking people if they like tea or coffee and collecting and putting on a pie chart? Or could it be using probabilities to calculate where particles are in reality? That is the wave function, by the way, if you don't know about it. So statistics is the study of data, and it consists of 3 chunks. So one is collecting data, one is processing the data, and then the final step is actually summarizing it. So summarizing data usually means drawing conclusions. So for example, if I give you this pie chart, you could draw a conclusion that more people like coffee than tea, but that could not be true. We look into that later on. But statistics, put it simply, is the study of dealing with events which have more than one possible outcome. So, for example, if you flip a coin, you can get heads or tails. If you go out and ask a random person on the street, on the high street, or a random person, what is their favorite drink? It could be tea, it could be coffee, it could be an alcoholic drink, it could be anything else, right? So that's where statistics comes in. All right. Statistics is the study of data again. So we're going to look at what is data and how we can process the data. So data is information, and it's unfiltered, uncontrolled information can be difficult to process, right? So to start off, you can start by filtering data. Data is characterized based on either its source or its type. So it's categorized as being primary data or secondary data based on how this data is attained. So for example, primary data is data you personally went out and acquired, and secondary data is data that's been given to you that's you have acquired through either a different company or through someone else. So primary data is usually more trusted, especially in research articles, mainly because they you give them credibility yourself. And secondary data is good, but it's not as reliable because you're trusting someone, right? And the data is also categorized based on its type. So we have looked at this in the previous series. We looked at quantitative data and qualitative data. Quantitative data focusing on numerical data and qualitative focusing on more sort of style data. So for example, you prefer coffee more than tea, that type of data, right? Most of statistics focus on quantitative data mainly because there's more numerical data there and it's much easier to work with. And there is a lot more to be done there. And it's more easier to put numbers and do math with it than putting emotions and doing math with it, right? So quantitative data is further divided into being discrete or continuous. Discrete data means that there's only so for example, you can only have certain values. So for example, shoe sizes, right? You can only have values like say shoe size 7 or shoe size 8 or 8.5. You cannot have a 7.1 shoe size, right? And continuous data is like height, which can vary over a wide range. All right. All right, the next thing we'll be looking at is variables. So in normal maths, right, we're used to having variables as terms. So for example, x, which we do not know the value of, right? But in statistics, there are quantities that can vary. So for example, if you flip 100 coins, how many coins will land on head? That is a variable, right? Or what is the probability that lands on head? That is a variable because we can change it and it's not a set value, right? So Variables also are further categorized as well, like data. So they're categorized as being quantitative and qualitative. All right. So quantitative data is further categorized as being discrete or continuous. And yeah, that summarizes variables in quickly. So the next thing we'll be looking at is population and population samples. So a population is basically all the possible data. So for example, if you want to get a population of the whole planet, you have 8 billion people, and you need to collect information from every single person, and that would be the population. A sample is a certain amount of people selected from a larger population that is a part of the data you're going to use, or else. So here are a few key terms I want you to get familiar with because these will be used throughout the course. They could be used in your exam. So a parameter is a numerical property of a population, all right? So for example, the mean number of left-handed people in the entire population. I mean, you could predict this using sampling, measuring the sample, apply it, but that is not a parameter. A parameter is like set values. They're sort of like rules, you could say. For example, the size of the population is also a parameter in itself, all right? A statistic is a numerical property of a sample. So a sample, same example here, so the mean number of people in this left-handed people in a sample is a statistic, all right? So statistic are things which you can use to use and change and do math with it to sort of show that it's like because a sample is like a chunk of the population. It's a representation of the entire population because you cannot represent the entire population, right? So a statistic can be used to represent an entire population, right? So that is why it's called a statistic because we do not know if it's accurate to the population, but we assume it is closely accurate. All right, this will bring us to the end of this video. In the next video, I'll be going through an example question and maybe another example question, just to help everyone get around the idea of statistics, parameters, and all the rest. All right. Thank you, and stick around for more.